And we're going to review homework assignment number 4 and issue drawing number 3. Okay, so what's a floor plan? And the reason we are asking this is because the next assignment is going to be a fundamental assignment on this class, because you are going to work on this assignment from now until the end of the semester. And so I like to make sure that you understand first how important it is, because once you select it, then you're going to work with it for the rest of the class. You can always change it, but that would mean, throwing away work that you may have done already. So, and I want to make sure that as we move into the next drawing, um, we have a pretty clear idea of what is it that we want him to do. And so it's important for us to understand what a floor plan is, what an elevation is, and what a section is, right? And all of you had good ideas. I could see in your submittal of the homework that you understand that. Now, let's kind of backtrack here and go back to the basics of maybe even the basics of drafting 120, and see what each of these views are. Trying to open something here in the computer is not working, so hang on a second. Okay, now it seems to be. All right. And so remember that in drafting 120, we did these drawings. We call them the isometric drawings. And so this is a three-dimensional object, and or a representation of a three-dimensional object, right? It's not really a three-dimensional object. It's just a drawing that represents that object. Now, if we are going to build a building, for example, or if we are going to make a product, any product, we will we typically design and show our clients a three-dimensional object, right? Something like this, or an artistic rendering of our project, right? And so we'll show something like this, right? Maybe we do a little drawing that shows what we are trying to accomplish, right? Maybe this object like that, or this object like that, or this 3D view like that. But the problem we have is that with these kind of views, what we want to build cannot be built. And so to building something that we want to get built, we need to have what we call true views. And we also call that orthographic projections. And so we need to extract the views from the object so that we can have views that we can measure with true dimensions. And so, for example, for this particular drawing, those views will be this, right? And so You can see here the top view of that, the front view from this side here looking that way, and the right side view from this looking that way. So we're all familiar with this because you actually did this drawing in Drafting 120. And so these views are called orthographic projections. They are projections from this object. And the one at the top is what we call a top view or a plan view. This one is an elevation view, and the same is this one, right? And so, but if I were to section this object at some point in time here, we'll get a floor plan. And if I get the section perpendicular to this view, then I'll get a section view. Something like this. Let me show you using my Revit example here. Right, so we have this building, right? And now I am going to activate the section box. This tool is called a section box. And so if I press the section box down like that, and I bring it so it is about 4 feet off the ground on that floor, and then I look at it from the top, then I get a floor plan view. And this is what a floor plan is. A floor plan is a horizontal section of a building about 4 feet off the ground or off the finished floor looking down. And on a floor plan, we see the walls that separate the different spaces in the building. And we see the layout of each space. So that's what a floor plan is. Now, a floor plan, if I go to this particular view here, that this is a drafting representation of that floor plan that we were looking at. And so in a floor plan, the walls are described with two lines, one line on the outside and one line on the inside. The distance between those two lines is a standard dimension that depends on what kind of materials that wall is made out of. In the United States, we use wood framing system that makes it so that this thickness on the outside we use a dimension of 6 inches for this thickness. And in the inside, we use a dimension of 4 inches for the walls on the inside. So we represent then a wall by using two lines. And then on those walls, we see windows as intersections or as breakups in those lines. See how the lines for the wall break it up, and then you see kind of a transition space there. And we can also see doors, right, breaking up the walls. Typically in a floor plan for a house, we will see, and I'm saying a floor plan, not a furniture plan. A floor plan will show the appliances and fixtures for the bathroom and the kitchen, but it will not show furniture. And that's what a floor plan is. Now, what is a section? Well, let's go back to the 3D. And I am going to turn the section box back on. And now I am going to move this in until I get a section view like that. And now I select the right side. And that is what a section view is. We create a section of the building, we take out one part, and then we look at what's left. And that's what a section is. Now, let me make this a more graphic section. So I'm going to go back here. Maybe I go to the first floor. No, that's fine. On the second floor, see if I have any. Yes, I do. I'm going to uncheck this. And I have a section there. Let me delete that and we'll do it again. So I'm going to use a tool called section view here. Section, click here and click there. And now I'm going to turn it around, look in that direction. That's exactly what I did on the three-dimensional plan. Now, if I double click on this, then I'm going to go back to that view and see that's the section view. It's the same that I had on that three-dimensionality before. Now, in a section view, what we see is not only the walls, but also the floor and the roof. We see the heights of the building, right? When in the floor plan, we saw the division of the space or of the house in terms of the rooms. Now in the section, I see the heights and the different levels of the building. And also, you know, we see construction systems and whatnot, but the most important thing is that we see the levels and the walls, floors, and roof, right? And so on the floor plan, we see the walls, doors, and windows. In the section, we see the floors, walls, doors, and windows, and the roof. Also, in this one in particular, we see the ceiling. We see the exterior walls and the interior wall. And so that's what a section is. We cut the building, we take away one part, imaginarily, right? And then we look on one direction. Once again, this is the section, and I'm going to be looking that direction, right? Double click. Says me to that. And that's it. That's what we have. And then the elevation. The elevation is very similar to the section, right? The difference between the section and the elevation is that in the elevation, I see the outside of the building. I see the side of the object, right? That's the elevation. That's the east elevation. We also have that here. That's a 2D elevation, right? And so we don't see the heights here. We don't see the different levels. We just see the exterior side of the building. I'm going to copy this and maybe go to the west elevation. And in here, you can see a lot of trees and whatnot. But what's important is that the object shows just the roof and the side wall, and then doors or windows that may be on that side. And that's all we see on an elevation, right? Now, this is true also, or the same views are true also for objects that we are drawing, right? If we are creating the design of an object, then we will have also top view or plan view. We will have also section views, and we will also have elevation views, right? And so and that's a common practice to do that, right? Because we need to create those views to be able to create the product, right? And so you can see here, where did it go? Oh, it's one of these. Oh, there it is. it's a section there of a product, right? It's a bottle opener. And so where we are looking at the third angle orthographic projection is the one used in the United States. This one is the most widely used in Europe. And there's a section there. So you can see for product design, we also do the same type of drawings, right? That we can do for architecture. And so once again, you can see here, also 3D object. Then we see the top view, similar to a plan view. And this is third angle orthographic projection in Europe, first angle, sorry. Section view of the object and an elevation view of the object. So it's important to remember then that all of these views that we're talking about in our homework are orthographic projections. That's the idea, right? And so that brings me then to the next drawing. What is the next drawing? So let's look at that. And the next drawing that we're going to do is called discipline-specific project. Now, remember, this is the project that you are going to be working with for the rest of the class, up until the end of the class in May. And so you are going to select the project. Select your own project to draw. And it's discipline specific. The options are 1 or 2 bedroom house, a kitchen and bath, one of each interior design project. It could be a landscape architecture project, a small area, or it could be a mechanical and industrial design assembly, 3 components max. Okay. So first you need to select the project. Are you interested in architecture? Are you interested in product design? Are you interested in interior design? Or are you interested in landscape architecture? Or in any other discipline of design? So you need to make your choice here. And then once you decide which discipline you want to do the project in, then you select which one of these applies to you. And then you are going to do a design development presentation that includes 1 or 2 floor plans or top views, 4 elevations or side views, and 2 sections. And you are going to present that using a typical design development presentation. We'll talk about that later. Now, this project is due in 2 weeks, right? And so the first thing that we need to do then is to make sure that you know what discipline you want to do the project on, and then and then you need to present that to me, the idea that you want to do. So I should approve that. And then you develop the presentation, right? And I'll work with you to make sure that the plan, the elevation, and the sections are accurate and are correct. Now, remember that when we talk about a building plan and a building sections, all we want to show is plans, is the walls, the doors, and windows, bathroom and kitchen appliances and fixtures. No furniture, no dimensions. I'm not asking for dimensioning or anything, but it needs to be to scale. Same for the section and same for the elevations. And it should apply the same if you're doing a product design, mechanical design, or other type of project. And so that's it. That's the idea, right? So for next class, what you need to do is to make sure that you have selected a project and that you talk to me about that in advance, right? I'm going to open now for questions and see if you have any questions regarding this. Any questions?
I had a question.
Yes.
So for So I'm interested in doing the 1 to 2 bedroom house. When you do that, we can just make up any house, right?
Yes, you
Like it
can do
doesn't.
that, or select a house that select a plan or a design that you find online or that you did
Oh,
before or
okay.
something like that.
Okay, and then for 1 or 2 floor plan views, like would you do we do like one floor plan view and one top view?
No, the floor plan is the top view if you're doing architecture. If you are doing
Oh, okay.
product design, the top view will be the floor plan.
Oh, okay. Okay. Thank you. That makes sense.
Okay. Any other questions?
Yeah, Armando, I got a question.
Yeah.
So for drafting 121, we're doing our own house. Can we use the same house and do all of the elevation drawings and floor plan, top views, and section drawings for it?
You could, but I don't know if you're going to have it on time,
Oh, okay.
right? Because the process is slower in drafting 121. But if you can, yeah, that works.
Oh, can I use the same floor plan that I'm using
Yeah,
in
you could
121?
if you already have it, but that floor plan is in flux in drafting 121.
Yeah.
I'm going to ask you to do many modifications and changes.
Oh, okay.
And so I don't know if it's going to be ready when you need to submit this.
Okay.
So because of that, it's probably better to find a different plan.
Okay.
And it could be a plan that you find online or that you've done before or somebody else. Yeah. So, or a house that is existing and you want to do the plan.
Okay. Yeah. I'll look for one online and see if I find one.
Okay. Sounds good.
Thank you.
I'm sorry. I have another question.
Yes.
So for the 4 elevations, that is basically just like the front of the house, the 2 sides of the house, and the back of the house, right?
Yeah. The elevations for any object are minimum 4 is the 4
Okay.
sides of the object.
Oh, okay. So then the 2 sections we could just do like we
Typically,
can.
in a house plan, we'll do one section on the long side and one section on the short side.
Oh, okay.
And you
Okay.
decide where.
Okay. Thank you so much.
Okay, thanks. Okay, any other questions? If not, then that'll be all for today. I will have an open lab today from 7:30 to 8:30. If you have any questions, want to show me any of the work you're doing for the current project, or anything else, that lab is open for both 131 and 132. All right. Well, thank you very much. I'll see you next time.
Wait, sorry. Can I ask one more question?
Yeah, you can still have more questions if you have to. I have 5 more minutes.
Oh, okay. So then for the assignment that we have for RA5, that one
For what?
on the RA5,
For this class?
yes.
Yeah. What's the question?
So then when it says to create the project process diagram for the next drawing, it's for this drawing, right?
For this project, yes. I want to
Okay.
see that done, and we'll talk about it next class, but similar to the process diagram that we use in drawing 2.
Oh, okay. Okay.
So
All
that
right.
shows how you are planning to organize your work.
Okay. Okay, thank you, Armando.
Thanks.